Now we are moving to the third and the last part in this lecture about the chemical method that can be used for the determination of milk proteins. In fact, we have got two categories of methods for this purpose. We have got physical methods and chemical methods. Physical methods involves turbidimetric methods, refractive index measurements, and absorption of UV light or ultraviolet light. On the other hand, chemical methods include Kildare method, formol titration, Biuret method, and Folin method. Physical methods, and as the name suggests, they are methods that make use of the physical properties of proteins. Those physical properties like the interaction of proteins with light. However, those methods aren't used in industry, in dairy industry. They aren't also used in dairy research. They are mainly used in research on proteins, on basic research on protein in other sectors, rather than applied sectors like dairy sciences. So we aren't going to address it in more detail. But we are going to focus more on chemical methods. Those methods are widely used in both research and industry. They rely upon chemical reactions of proteins, as we are going to see in a minute or so. And as I have just mentioned, they are very common methods for the determination of milk proteins. We are going actually to focus on two methods, two chemical methods. We mentioned four chemical methods, but we are going to discuss only two because those two are the most widely used in industry and research. Those are Kildare method and formol titration. Kildare method it is actually a very classical method that was invented in 1883. So it is more than a century ago, and it was invented by a chemist from Denmark. His name was Johan Kildare. So that's why the method is called Kildare method. It is very widely used for the determination of protein. No, it is actually defined, or it was actually devised. This method was devised to the determination of nitrogen content rather than the protein content. So it was originally developed for the determination of nitrogen content in various materials, including foods like milk and dairy products, fertilizers, and other substances. So this is very important point. This is very important point about this method, that it is not for protein, but it is for nitrogen. But why are we using it for the determination of milk proteins? Because nitrogen is a major element in protein. Milk proteins contain approximately 16% nitrogen. So if you manage to measure the amount of nitrogen in a milk sample, then you can convert this amount of nitrogen into protein content. Nitrogen can also exist in other compounds other than proteins, in non-protein compounds, but it mainly exists in proteins. I need to show you this table that illustrates the presence or the amount of nitrogen in various foods. As you can see, nitrogen exists in meat, in maize, zora, milk, flour, egg, gelatin, soya, rice. The highest nitrogen content can be found in gelatin, 18%. Meat, maize, milk, and dairy products have comparable or similar nitrogen content of around 16%. If you divide 100 by the nitrogen content in each food, you will get the so-called conversion factor. So for instance, for milk, if you divide 15.66 by, if you divide 100 by 15.66, then you will get 6.38, which is the conversion factor. This conversion factor is used to convert the nitrogen content measured by Kildee method into protein content. So protein percent equals nitrogen percent multiplied by F, which is the conversion factor. And the conversion factor can be calculated by dividing 100 by the nitrogen content. So what is the technical principle of Kildee method? Kildee method relies upon measuring nitrogen in samples, in food or fertilizers or any other samples, and it can do this by converting all nitrogen in the sample into ammonium ions that can be then titrated and measured. So in Kildee method, you need to carry out 3 successive steps. 3 خطوات متتالية. Those are digestion, distillation, and titration. The first step, digestion, is for converting all nitrogen in the sample into the form of ammonium ions. And to do this, you need to add sulfuric acid and some catalysts and expose the mixture of milk sample, sulfuric acid and the catalyst to a very high temperature. This causes some sort of digestion, هضم, digestion of sample. And in fact, digestion involves oxidation and reduction reactions, since the addition of sulfuric acid in the presence of catalyst and high temperature would cause the oxidation of carbon into carbon dioxide and hydrogen into water, and it would also cause the reduction of nitrogen into ammonium ion. Nitrogen is reduced to ammonium sulfate since we add sulfuric acid. The next step is to separate those ammonium ions or ammonium sulfate from the digestion mixture. And we can do this by the second step, which is called distillation. Distillation, the purpose of distillation here is to separate ammonium. This stage starts with the conversion of ammonium sulfate into ammonium hydroxide. Since ammonium hydroxide is more volatile than ammonium sulfate, we can do this by simply adding sodium hydroxide to the digestion mixture and then expose it to water vapor, بخار ماء, that can volatile. So when ammonium hydroxide is exposed to vapor, it can leave the solution and in the form of a vapor within the vapor. Then this vapor containing ammonium hydroxide is condensed. It is converted from the gas state or gaseous status into a liquid status by condensation. So it turns from a volatile gas status into a liquid status by condensation. So the purpose of distillation, as I mentioned, is to separate ammonium, but in this case, it's going to be separated in the form of ammonium hydroxide. In this stage, also in the distillation stage, we collect the distillate, which is a product of distillation after condensation. We collect it in a flask containing some sort of inert solution like boric acid solution or something like this. And then we collect it in this solution and then we titrate it. So the third step starts. The third step, which is titration, it is about neutralizing the amount of collected ammonium hydroxide and boric acid in the flask by a suitable acid. And the result or the amount of acid used for neutralizing ammonium hydroxide is calculated and used for the calculation of nitrogen content. Then we convert the nitrogen content into protein content by multiplication by the conversion factor. So these are the three steps of Kildee method: digestion for the conversion of nitrogen into ammonium ions, distillation for separating ammonium ions in the form of ammonium sulfate that is then converted into ammonium hydroxide to separate those ammonium salt, to separate them and collect them, and finally titrating them in the titration step. Here is a photo of how you can do the digestion. You can do the digestion step by simply putting the sample, milk and dairy product sample. After weighing it, you need to weigh the sample at the beginning. Then you add sulfuric acid and catalysts. And you add all of these in a flask called Kildee's flask. Expose this mixture to temperature for a lengthy time. It may take an overnight. It may take a day using this Kildee flask. Or you can use another apparatus or instrument like this one. It contains several flasks, Kildee's flasks, and those flasks are exposed to higher temperature so it can achieve the digestion in shorter time. And there is a more modern instrument. It's called hot plate. In hot plate you expose tubes containing the digestion mixture to a very high temperature ranging from 300 to 350. So the milk components or the milk sample can be digested very rapidly, but you still need around 3 to 4 hours for completing digestion. And here is the setup, the experimental setup used for carrying out the distillation step. As you can see, here is a flask containing the digestion mixture, and you add sodium hydroxide into it, and the water vapor would evaporate ammonium hydroxide that can be then condensed using condenser and collected in the form of liquid in this yellow solution like boric acid or any other inert solution. Finally, you titrate the collected amount of ammonium hydroxide in this solution against a suitable acid to assess the amount or content of nitrogen. As you can see, Kildee method is quite lengthy method. It takes time and it also takes effort. You need to do all the three steps on your own. You need to set up all the flasks, put the reagents yourself, waiting for the reagents to interact with each other and to get a results, etc. So to save time and effort, some commercial companies started to develop instruments that can automate the digestion and the titration process. So all you need to do is just to weigh a milk sample and mix it with sulfuric acid and the catalyst. Put all of these in a tube, place it in a hot plate, and after digestion, you put the tube into an instrument that can do the distillation and titration steps automatically. You wouldn't do anything more than just reading the result on the screen. I would invite you to watch out this video that would illustrate how such a semi-automated Kildee instrument works. Okay, so let's move to another method, which is the formol titration. Formol titration It was invented after the Kildare method. It was invented in 1907, and the inventor was another scientist from Denmark. His name was Søren Sørensen. Søren Sørensen is famous for his invention of the pH scale. The pH scale we know ranging from pH 7 for neutral solution, lower than pH 7 it is for acidic solution, and higher than pH 7 is for alkaline solution. This scale was invented by this guy, Søren Sørensen. Søren Sørensen has also invented the formol titration, and it was originally introduced for the measurement of amino acids, not proteins. But since proteins contain amino acids, then by determining the amount of amino acids, we can determine the amount of protein. In fact, formol titration has an advantage over the Kildare method, because formol titration is more rapid and it is less expensive and it takes less effort, whereas Kildare method it takes a long time, or it takes a longer time, it is more expensive, and it takes effort. As I mentioned, you need at least from 4 to 5 hours to conduct protein analysis using the Kildare method. But in the formol titration, you only need from 5 to 10 minutes to get a result. However, formol titration is less accurate than Kildare method. Kildare method is more accurate than it. That is why Kildare method is preferred in research, but formol titration is more preferred in industry, since in dairy industry, the factory, the dairy factory receives lots and lots of milk and dairy product samples, and there is a need to analyze a large number of samples in a short time. So formol titration, although it is less accurate than Kildare method, it is more preferred in industry since it takes less effort, it takes less time, and it is less expensive. But what is the technical principle of the formol titration? The technical principle of formol titration, it is based on what we have just mentioned about the amphoteric property of proteins. What is the amphoteric property of proteins? It is the property that allows milk proteins to react with acids as bases and with bases as acids. And this happens because of the presence of both acidic and alkaline groups in the side chains of the amino acids in proteins. So this is the basis of the formol titration. The technical principle centers on this part, or on this aspect. In formol titration, we just need to add formol or formaldehyde, which has an acidic effect, to the solution. Formaldehyde, with its acidic effect, is going to interact with alkaline groups in the side chain of amino acids. This way, the acidic effect of the acidic group in the side chain of amino acids will appear. And if we add an alkaline solution to neutralize this acidic effect from the acidic groups of the side chains of amino acids, then we will be able to have an estimation of the amount of protein. So all you need to do when you carry out a formol titration is to bring a defined volume of milk, let's say 10 ml of milk, and you neutralize the natural acidity of milk by using sodium hydroxide, and then you add formaldehyde for a few minutes. So with the addition of formaldehyde, the alkaline groups will be bound to formaldehyde, and the acidic groups in the side chain of the amino acids will start to show their acidic effect. So the acidity of milk will increase again. And if you neutralize this increase in acidity, you will have an indication or a measurement of the amount of protein or content of protein in this sample. It's quite a simple technique, and you can do it in just from 5 to 2 minutes. Well, that's it for the determination of milk protein. I wish you the best of luck, and hope you will understand this lecture and send me out any questions you may find relevant to the topic of this lecture. Thanks a lot, and the best of luck to all of you.